We're talking about a game changer. Game changer that's going to change the landscape.
But just as we once made a dramatic shift from making looms to making automobiles.
Hello, car enthusiasts. You may think you know everything about the future of cars, and maybe you even have it in your mind that EVs are the ultimate answer to clean transportation. But what if I tell you that everything you've been told about the future of cars is wrong? I say this because Toyota recently made a big bang that could change everything. While other car makers were introducing their new models against the backdrop of big screens, Toyota was cooking up something behind the scenes that was enough to stun the entire auto industry. In a rare, candid statement, Toyota's CEO stole the headlines with a message that very few expected. Our new dynamic force engine will spell the end of electric cars. This was no simple announcement. It was a clear warning. It was a sign that Toyota is no longer content to stay in the background. So what exactly is this engine? And why is Toyota so confident that it will outshine everyone else? Let's uncover the real story behind Toyota's boldest move yet. But before moving ahead, don't forget to hit the subscribe button so that every new update from the auto world reaches you first. Now let's talk about the rise of Toyota's dynamic force engine strategy. Toyota is not just improving its engines, it is changing how they work to meet future needs. With its new dynamic force engine series, Toyota is focusing on improving fuel engines, while many other companies are switching completely to electric vehicles. These engines are not small updates. They are part of a long-term plan connected to Toyota's global design system called TNGA, or Toyota New Global Architecture. This system helps Toyota build cars that are stronger, more efficient, and easier to produce. While many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota said that the new dynamic force engines are a big part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still give strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas while also meeting environmental rules and keeping costs low. The new dynamic force engines are designed to work with Toyota's TNGA platform. TNGA is a system that allows different cars to share the same parts and design. This helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes, like switching to new types of fuel. The dynamic force engines focus on more than just speed or power. They are built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency. This means the engine can turn more fuel into usable energy rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. Cooling systems are also more advanced. Electric water pumps and better temperature control help the engine stay at the right temperature. This makes the engine last longer and work better in different weather conditions. Every part of the engine was designed with care to support both performance and fuel savings. The Dynamic Force series includes 3 types of engines: a 3-cylinder, a 4-cylinder, and a V6. The i3 is small and uses less fuel, which is good for compact cars. The i4 is the most common type, found in many mid-size cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be built in different countries with local parts. This saves time and money while quality remains high. It also helps Toyota deal with supply issues or changing demand in different regions. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. For example, if a market needs more ethanol-based engines, Toyota can shift resources without making major changes. This kind of flexibility is useful in today's fast-changing industry. Now, let's see how it helps Toyota compete. The Dynamic Force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is improving them to meet both current and future needs. These engines are ready for multiple types of energy and work well with hybrid systems. This makes them useful in many markets, especially in places where electric vehicles are still not practical. The new engine design, along with the TNGA system, helps Toyota keep costs low and quality high. This means customers get cars that are efficient, dependable, and ready for future updates, all without giving up performance. By using TNGA, Toyota can produce many vehicles with fewer changes in the production line. It also makes it easier to add new engines, like the Dynamic Force series, across many models without changing the entire car. This speeds up development and lowers costs, while still allowing each car to have a unique style and function. One of the main goals of TNGA is to support new technology. That includes not only better safety and comfort features, but also new types of engines. The Dynamic Force engines are designed to fit perfectly within the TNGA layout. This means engineers don't have to redesign the car every time they improve the engine. This helps Toyota stay ahead in markets where clean energy is growing quickly. By building flexible cars that support different powertrains, Toyota can adjust its lineup without big design changes. This is a major advantage in today's auto industry, where energy systems are changing fast. Several cars built with TNGA and Dynamic Force engines are already on the road. Models like the Toyota Corolla, Camry, and RAV4 use this setup, and they have seen improvements in both performance and efficiency. Drivers notice better fuel economy, quicker response, and smoother driving. For Toyota, these results show that the TNGA system works as planned. It supports fast changes, reduces production time, and helps introduce new engine technologies across many models. This gives the company a strong position in both traditional and emerging markets. Every major leap in automotive progress begins at the engine. For Toyota, the Dynamic Force engine represents the next stage in internal combustion design. These engines are not simply a tweak of the past. They are a complete redesign of how power, efficiency, and emissions are balanced. Developed from scratch and built to pair with Toyota's TNGA platform, the Dynamic Force family brings a focus on thermal efficiency, smart air fuel management, high-speed combustion, and mechanical precision. Toyota's engineers set out to achieve what most considered extremely difficult: increasing thermal efficiency in a gasoline engine to levels typically seen only in hybrid or diesel powertrains. In internal combustion engines, thermal efficiency refers to how much of the fuel's energy is converted into useful work. Traditional gasoline engines tend to have thermal efficiency in the range of 30 to 33%. The dynamic force engines break past that limit, with figures reaching 40% in gasoline-only configurations and even 41% in hybrid setups. This improvement comes from a combination of technologies working together. Instead of focusing only on one system, Toyota looked at how each part of the combustion process could be enhanced. That includes how fuel is delivered, how air flows into the cylinder, how the combustion chamber is shaped, and how heat is managed during ignition. Improving all of these areas led to the record-setting efficiency numbers Toyota now claims. Dual injection system. One of the biggest changes in Toyota's dynamic force engines is how the piston moves inside the cylinder. These engines are built with a longer piston stroke compared to older designs, meaning the piston travels more vertically. This design boosts the compression ratio and improves how efficiently the engine uses fuel. For example, the 2.5-liter Toyota engine can have a compression ratio as high as 13:1 or even 14:1, depending on the version. A higher compression ratio burns the air-fuel mixture more completely, leading to more power and less wasted energy. But there's a catch. Higher compression can also cause engine knock, which happens when the fuel ignites too soon. Toyota avoids this by using smarter cooling systems, better spark timing, and precise fuel delivery. It's all about balance, getting more power without hurting the engine. And Toyota's engineers have managed it by making thoughtful improvements in many small areas. Fuel injection has been one of the most significant upgrades in engine design over recent decades. Toyota's dynamic force engines feature a high-tech setup called D4S, which combines both port injection and direct injection. Port injection sprays fuel into the intake manifold, while direct injection sends it straight into the combustion chamber. Each type has its benefits. Port injection helps clean the intake valves and works well at low engine speeds. Direct injection creates a finer fuel mist and boosts power, especially when the engine is working hard. Toyota's D4S system smartly blends both types, switching between them or using both at once, depending on what the engine needs. This dual system improves both power and fuel economy. It also helps reduce emissions by keeping the air-fuel mix as precise as possible in every driving situation. Whether you're easing along in traffic or putting your foot down on the highway, the engine instantly adjusts for top performance and efficiency. To take airflow and combustion to the next level, Toyota has upgraded the materials and methods used in making the engine head. One clever upgrade is laser-cladded valve seats. In this process, a durable metal coating is applied to the valve seats using a laser, making the surface smoother and more resistant to heat. This helps create a better seal, reduces wear, and ensures steady combustion throughout the engine's lifespan. Toyota also boosts airflow into the engine using ultra-precise machining. The intake ports are polished until they're almost mirror smooth, cutting down air resistance and improving how air flows into the cylinders. Better airflow means more oxygen for each combustion cycle, which increases power and efficiency, all without needing a turbocharger. Variable valve timing has been around for years, but Toyota's version in the dynamic force engines adds a smart twist. Traditional systems rely on oil pressure to shift the timing of the valves. Toyota replaces that with an electric motor on the intake side, a system called VVT-IE. This change allows the engine to adjust valve timing more quickly and accurately, especially during cold starts or light driving. Why does this matter? Because valve timing affects how well the engine breathes. With better control, the engine can easily shift between fuel-saving and high-performance modes. It also improves how the engine responds and lowers emissions, especially useful when driving in stop-and-go city traffic. Another standout feature is Toyota's updated cooling system. Instead of relying on a single coolant path, these engines use multiple channels that target specific parts like the cylinder head, engine block, and exhaust valves individually. This smart design helps the engine warm up faster when starting cold and then cool more precisely once it's running at full temperature. A quicker warm-up lowers emissions, while accurate cooling helps the engine stay strong and perform better for longer. Sensors are always monitoring the temperature and adjusting coolant flow to fit the current driving conditions. It's a clever system that helps the engine stay efficient and reliable in all kinds of weather. Friction is one of those hidden things that quietly takes away from engine performance. Every part that moves, whether it's pistons, camshafts, or valves, creates resistance that uses up energy. Toyota engineers focused hard on reducing this friction in every corner of the dynamic force engine. They added low-friction coatings on the piston skirts, used roller rocker arms in the valve train, and optimized how oil flows through the engine to cut down on drag. Even the timing chain was redesigned to produce less friction and noise. Each change might seem small on its own, but together they create a smoother, quieter engine that uses less fuel and lasts longer over time. Toyota built the dynamic force engine with tough worldwide emission rules in mind. To cut down emissions right at the source, the engine uses quick-reacting oxygen sensors and high-capacity catalytic converters. The catalytic converter is also placed closer to the engine, so it heats up faster and starts working sooner after ignition. In hybrid models, the engine can shut off during light driving, letting the electric motor take over. When the engine kicks back on, it does so quietly and cleanly. This is a great example of how Toyota's TNGA platform and the dynamic force engine work hand in hand. The system is designed to support both gas-only and hybrid power, and the software helps shift between them smoothly. While most vehicles still run on gasoline, Toyota designed these engines to handle other fuel types too. In some areas, ethanol is widely used. In others, engines need to work with low sulfur or blended fuels due to local laws. Toyota tested these engines with ethanol and confirmed they're compatible with flex fuel systems. The company is even exploring hydrogen as a fuel for combustion engines. This isn't like hydrogen fuel cells. In hydrogen combustion, the engine burns hydrogen just like gasoline, but the byproduct is mostly water vapor. One example of this is the GR Corolla H2 project. It's still in the early stages, but it shows how versatile and forward-thinking the dynamic force engine design really is. The backbone of the TNGA strategy. Toyota's TNG, a platform, isn't just about better looks and stronger vehicle frames. It's also a smart way to roll out new engine tech on a global scale. Since TNGA was designed from the start to work with the dynamic force engine family, Toyota can easily mix and match different engine sizes and hybrid setups without doing a full redesign each time. This flexible system means Toyota can use the same basic engine design across the globe while still meeting local needs and regulations. It speeds up development, cuts down production costs, and gives drivers around the world a more consistent and refined experience. Whether someone is buying a Camry in the US, a RAV4 in Europe, or a Corolla in Southeast Asia, the core engine technology stays the same: efficient, reliable, and ready for the future. The first models to feature dynamic force engines were some of Toyota's most important global vehicles: the Camry, RAV4, and Highlander. These cars were also among the first to switch to the TNGA platform, making them ideal candidates for the new engines. In the Camry, Toyota launched the A25 AFKS, a 2.5-litre four-cylinder gasoline engine producing around 203 horsepower, paired with an 8-speed direct-shift automatic transmission. A hybrid version was also offered, delivering 176 horsepower from the gas engine and up to 208 combined horsepower with the electric motor. The result was a big improvement in acceleration, a quieter ride, and hybrid fuel economy reaching nearly 50 miles per gallon, beating out competitors like the Honda Accord Hybrid and Hyundai Sonata Hybrid. Next came the RAV4, which also adopted the A25A engine in both its regular and hybrid versions. For a compact SUV, this engine gave the RAV4 impressive performance. Its hybrid model quickly became the best-selling hybrid SUV in North America, thanks to over 40 miles per gallon fuel efficiency and lively driving dynamics. The success of the RAV4 hybrid showed that Toyota could scale up this new engine technology across its lineup, while still keeping things practical and dependable. In bigger vehicles, like the Highlander, the same 2.5-litre dynamic force engine powers the hybrid models, replacing the older V6 hybrid systems. Even with a smaller engine, the new setup delivers 243 total system horsepower and gets up to 36 miles per gallon combined. A huge leap in fuel efficiency, while also meeting strict emissions rules in both the US and Europe. After proving itself in mid-size cars and SUVs, Toyota began rolling out dynamic force engines in smaller vehicles too. Toyota's dynamic force engine isn't just a technical upgrade, it's a statement, a reminder that the internal combustion engine still has fight left in it, and Toyota isn't ready to give up its crown without a battle. As rivals rush toward full electrification, Toyota is quietly building something far more strategic, far more calculated. But in a rapidly changing auto industry, will this bold engine be remembered as a masterstroke or a missed opportunity? Let us know your thoughts below. Don't forget to like and subscribe.